Thank you very much for being here. We know it's a little bit late. We know there's a break right after this. We're trying to keep you entertained. So my name is Pato. I'm Ramiro with me here. We both work for a company called ASAP. I'm going to talk about it in a minute. It's called ASAP. That's how we pronounce it. We're both in the SRE team. We're both staff SRE engineers. I noticed that people have been putting their contact information at the end. We should have done that, but here's our Instagram and LinkedIn contact information if you want. So a couple people stole my joke about this yesterday, but we can't go 2024 without mentioning AI in a tech conference, blah, 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 whatever. But in this case, we are talking about the company that we work for. So ASAP, we are a company that creates or has Gen AI solutions for contact centers for companies that have to have end customer contact. So think about when you've talked to your bank, your airline, hotel, etc. So instead of having to call and have an analog call with one human, try to make that more digital, more smarter, and kind of have a different way of interacting with it. So this is not a pitch for the company, but just there's a couple of numbers here of the successes we've had with our customers. And just so you get an idea a little bit of what kinds of challenges and problems we deal with and we have to address. Right? So very short agenda of what we're going to talk about today. So the sort of larger topic is our migration to Grafana Cloud from our previous observability vendors and kind of fragmented observability stack into Grafana Cloud. Then we're going to address or talk a little bit about the main problem or the main thing that we're going to address here or talk about in this talk, which was the creation of the dashboards. But first of all, pin the picture of what the problem was, how we solved it, and getting a little bit of technical details on that solution, and then a demo to kind of tie everything together.
Okay, so let's start talking about how we moved to Grafana and why we did it. Many of the reasons have already been covered on this conference, but let's go through them really quickly. So basically, over the years, we have accumulated a number of problems and issues and things that we wanted to improve. One was that we were actually having many vendors for our solution. So if you wanted to check metrics, you will have to use one UI. But then if you wanted to check logs or traces, it was like a different UI. It was painful to use and really hard to correlate between those. So for us, Grafana was like a perfect fit here because we can see everything in one place, but also it supports a lot of data sources. So it's a little bit related with the integration and how we wanted to abstract and grow our system. The fact that it supports many data sources actually allow us to, for example, have our own system we have integrated with the JSON data source. So we can keep adding more stuff into our observability stack. Then, of course, cost was an issue. We wanted to get the most value out of each dollar that we spent, but also the model pricing that we were having was based on host or number of services, and we were running on Kubernetes, so we have a ton of hosts and a ton of services. So moving to a model pricing based on volume was really a good fit for us. And then again, adaptive metrics, we ended up using that and save us. It was like a quick win for us to show. So yeah, use adaptive metrics. Then team onboarding was hard. Again, multiple vendors, multiple different UIs, so the system was a little bit complex. Having just one vendor make it a lot easier, but we also like the philosophy that Grafana is using for the query language. Like if you know PromQL, then there is some things that at least you can apply on LogQL and TracesQL. So it make it a little bit easier to transition from one query language to the other. And also there is a ton of documentation and information online, so it's simpler to get onboarding. And lastly, vendor lock-in. This has already been covered on the conference, so I'm not going to talk a lot about that. But one of the things that we like is since many of the products Grafana is using for cloud are actually open source, we can actually choose which part of the stack we run in Grafana Cloud and which we run on-prem. So let's go quite fast over how our architectures look like now that we are using Grafana Cloud. So Most of our services running in Kubernetes are instrumented, so they are producing all the signals, metric, log, and traces. And we have agents for each of those. We were already using Loki for logs internally in our own on-prem stack. And we keep it that way because we were happy with it, it's working. We didn't want to move it. But then we choose Mimir and Tempo, both running in Grafana Cloud for our traces and metrics. But we also run Prometheus and Thanos internally. And we basically do that because for our lower environments, like test and station environments, we actually don't need such a high SLA or like a long retention period. So we have like a smaller setup there where we can send our metrics. And the nice one of the nice features is that the instance that we have running in Grafana Cloud, the Grafana instance that we have in Grafana Cloud, is actually able to talk with all those backends, even the ones that we run on-prem. So it's like a unified view for our users. So let's talk a little bit about the migration. And again, I'm going to be quite fast. And to be honest, there is a ton more that we could say about the migration, but we're trying to focus the talk about dashboards. So keep that in mind. So we have like 3 million active series that we have to move into Grafana Cloud. And then we have like 60 terabytes of traces. We were able to reduce that number a lot by using sampling. But then we have like 400 dashboard, which was sort of a mess, and we're going to talk a little bit more into detail for that. We did reduce that number a lot over the migration, but yeah, let's go over those in a little bit. So some of the challenges that we have at the moment were that some of the tools that we wanted to use for the process that we have envisioned were not there yet. So we wanted to manage our dashboards through Kubernetes using a controller, but there was no controller available at the moment. Nowadays, you can actually use the Grafana operator for this, but since there was nothing there at the moment that we were moving it, we actually created our own. And then we wanted to simplify the process, so we built our own CLI to manage most of the life cycle of dashboard creation and update. And then we build a little visualizations and tools that allow our developers, which are the users of the observability stack, just to see if there was any error, why their dashboard was not created, or what's going on there. And then let's talk a little bit about onboarding and moving from one system into Grafana Cloud with all these changes. I mean, besides the migration itself, we were also changing the process and the tools that teams will have to use. I think many of these things have already been covered, but basically we have documentation in place. We did try to simplify the process as much as we could so that it was easy to adopt, and that's why we built all the tools that we could think about to make it easier. And then, since this was a process that we were going to use for the migration, but we also wanted to keep it using after the migration and make it the standard way to interact with the system, we actually used the migration as a sailing point for the whole process. So if you follow the process and you use the tools that we had put in place, the migration was actually a lot easier because teams will have to translate the dashboard that they have in the old provider into Grafana Cloud, the PromQL. And so using the tools that we have in place make it a lot easier. And finally, of course, we have demos and office hours, so that you not only read on how to do the things, but you can actually see it in action and see it working.
All right. So like I mentioned earlier, one of the main things, one of the main pillars of this migration was the ability to, for service owners to still have that observability, that visibility into the performance of their systems as they were live, as their incidents happen and whatnot. So because we have a lot of other things within the company and in general as declarative definitions, like infrastructure as code and some other things, we wanted to kind of have the same concept with dashboards. As most of you know, it's nearly impossible to write a dashboard. It's like the whole JSON model from scratch manually. You can use SDKs or other things, but the idea of having people create their dashboards from scratch the same way or with the equivalent dashboards that they had in the previous vendor was impossible. So we wanted to have something that was more of a full workflow from scratch to visualizing and sharing the dashboard. So we created this. It's not a revolutionary concept of dashboard as code, but we want to take that concept to this. One of the main problems within that realm of dashboard management was the dashboard dispersion, what we're calling. So there was no clear process or definition how to create a dashboard, how to contribute to a dashboard, how to share it. The organization or the hierarchy within directories was kind of non-existent. It was hard to trace who the owner of the dashboard was, what service it was monitoring. We ended up with dashboards with names like Pato's dashboard copy to -extra or something like that, and it was hard to create or follow the progress or the evolution of a dashboard as it was modified. And often people would find it hard to contribute to a dashboard that was almost what they wanted, but not quite, so they ended up copying it. So all these things that caused diversions and not like the lack of convergence of dashboards led us to try to solve this problem. So we wanted to create, again, not just the dashboard definition as code, but have a full life cycle of managing it from creating it to deploying it or visualizing it in a shared manner that was as automated as possible. So we ended up with this kind of Grafana, Git Grafana sort of cycle. The main part of it, the first part of this rather, is give users a tool for creating dashboards visually, so that because that's basically the main way that everybody that uses Grafana ends up creating a dashboard or creating a visualization. It's much easier to create it visually than it is to create it or to try to find a way of doing writing the JSON definition. So have a tool to be able to build that dashboard visually, and then capture that as code, not as stored it in Grafana, but as code, put it in Git, and then from Git, push it to Grafana Cloud via the Dashboards API, so that it's able to visualize it and share it with other people. So we're going to get into a little bit more detail about that. So how we did this. I'm going to try to keep it high level and sort of get into some technical details if needed. But these are the 5 main components of the solution. Obviously, Grafana Cloud is at the top because we're building everything on top of this. There's nothing critical that is about Grafana Cloud, but we are migrating to the Grafana Cloud. So that was at the top of the solution. So Kubernetes, we already have most of our, I guess 99% of our workloads on Kubernetes. We have a lot of, not just running the workloads on Kubernetes, but configuration injection, deployment pipelines, integration, et cetera. So like Kubernetes was the ideal platform on top of which build a solution. Argo CD, not getting into a lot of detail, but if you're familiar with it, is it's not quite a CI/CD platform, but it's more like a continuous GitOps platform of sorts. Runs on top of Kubernetes, and it can deploy Kubernetes objects through its API. Then we wrote a custom controller. This is going back to Kubernetes. That there was an automated controller, a controller that was automatically synchronizing definitions of dashboards to the Grafana Cloud Dashboards API. We did that using a framework called Operator SDK, and then a custom CLI for managing the first part of it, which is creating the dashboards visually. Without getting into a lot of detail, that's kind of what the process ended up looking like. So on the bottom was a user is managing a dashboard that didn't have to have that name, but it's a dashboard.yaml file that contains the definition of it. User would run the graph command, which is the tool that we created. We're going to talk about, double click on it a little bit later. Start a dashboard. It would show a temporary dashboard in a kind of sandbox area of Grafana Cloud. Then instead of storing it as a dashboard in Grafana Cloud, the graph tool would download the JSON model, put it in a file, and then the user would commit it to Git. The changes in Git would be picked up by Argo CD. Argo CD would deploy them to Kubernetes. Within Kubernetes, the operator, the automated controller was running, and it was talking to the Grafana Cloud API on a production area. and creating the dashboard by itself that was shared with the rest of the organization. Stepping back a little bit, before we started with like producing or creating this large scale solution, we wanted to make sure that we were solving the right problems, and we wanted to have some document or some guideline that we can turn and say, we did solve these problems. We didn't want to like go start getting creative and then start solving problems that were in there. We wanted to fix or address these 5 things. So one thing is, because we were deploying this as code, we wanted to have or deploying dashboards as code, we wanted to keep the code for the dashboards as close as possible to the application code, and to the extent as possible to the configuration, which is the Kubernetes deployments and Kubernetes manifests and all that. So the ideal goal was that it would live in the exact same repository, be in the same branch and versioning, et cetera. So that was one thing. Other thing is we didn't want to get on a wrong foot and start without a process for creating dashboards and end up with the same mess that we ended up with the previous vendor. So we want to establish a clear process for this. And it wasn't obvious at the beginning what the process was going to be, but we always knew that we wanted to have something that was clear, unique, no edge cases, no conditionals, et cetera. Anybody, regardless of what their stack or what their programming language was, would create the dashboard the same way. Read-only access is part of the process because we wanted people to be able to visualize anything that they deployed and keep it open to the entire company to the extent that's possible, but only be able to create dashboards through the established process, which is not through Grafana Cloud or not through like the Grafana UI, but rather through the workflow that we ended up creating. So with also the other problem that I mentioned earlier is tracking the ownership of a dashboard, whether to a specific person or to a team or to a microservice or a microservice owned by a team. It was almost impossible before because we were not imposing any standards, we were not doing any kind of automated tracking. But now we wanted to fix that, so that's what we ended up with, but it was clear to us that we wanted to have that as one of the main goals. And kind of tying everything together, make Git the source of truth so that what's defined in Git is what's deployed and only that's deployed. There's no way of modifying things externally. There's not a way of like cheating and working around the process. That is the only thing that gets created. Okay, getting a little bit technical here. I hope you stay with me. So the controller, there are different names for it, but controller and operator, they're kind of interchangeable. But it's a service or a workload that's running within Kubernetes that's running in a loop that is reconciling some definition with some API. It might not be clear, try to be as kind of broad as possible, but hopefully it'll make sense in a minute. So don't want to get into a lot of details because this is outside of the scope of the talk, but Operator SDK is a framework for creating workloads like this, operators like this, that runs in Kubernetes, abstracts out a lot of the complexity of talking to the Kubernetes API, such as authenticating, listening for events, generating metrics off the operator itself, and all those things, so that the only thing that's left is for you to implement the logic of the thing that you want to synchronize or to orchestrate between APIs. Because it's meant to be run for Kubernetes, this is obviously like a great fit for us. So doing this way enable this to be a continuous GitOps operation rather than have something that's pipeline based that would only guarantee that things are synced at the moment that you run the pipeline. But with this, the definition is continuously being synced and continuously being reconciled, so that guaranteed that the definition was what was there, and there's no cheating, no kind of going around the pipelines. And the Operator SDK allows you to integrate with external APIs as well. It doesn't need to be something that runs within Kubernetes. In our case, we were able to integrate Kubernetes objects and Kubernetes definitions with the Grafana Dashboards API. Very briefly, this is what the reconciliation loop ended up looking like. This is a more generic model of how Operator SDK works, but in our specific case, so this at the bottom is the operator or the controller. This is what's running the logic. back up a little bit, the user is modifying, so if you're familiar with Kubernetes, we have a config map, which is basically just a key value pair, a document with a key value store of things. We end up storing the entire dashboard definition there in a config map object. So the user, I'm simplifying it here, the user's not modifying the config map, the user's modifying the config map. It's not modifying the config map with the Kubernetes API directly, it's modifying it through the established process, source in Git. So once it's in Git, the operator, well, once it's in Git, Argo CD deploys it, then the operator watches for changes to config maps or the creation of new config maps, parses the contents of that where actually it doesn't part of it, just takes the whole definition and then talks to the dashboards API in Grafana Cloud to either create a new dashboard or modify an existing one. And as long as the config map is deployed to a specific namespace and has specific annotation, then operator would do that. And then lastly, just update the status of the config map too, so that it's more for feedback and visibility purposes to be able to know when something was created. So the end result that we had was that we were able to turn something that's as ugly as this. Obviously, this is far from the full definition of a dashboard. You can see it's the first, 20 lines of 30, 40, whatever, 200, 300, 400 lines. Probably way more if your dashboard's too more complicated. So turn something like this that's impossible or almost impossible to write by hand into this that's something nicer and prettier. Obviously, the numbers there don't look pretty, but forget about that. This is like the visualization itself is what's pretty. And this is, by the way, this is exactly what the author of the dashboard created visually. It was stored in Git and it was deployed like this.
Okay, so let's go over the CLI tool that we call it Graph because we suck at naming things. But basically, why we did it, we wanted to remove friction so that adoption was easier. So we tried to remove any manual step or automate it as much as possible. But then we were also doing this huge migration, and we wanted teams to own their own dashboards. So they will have to do the migration themselves, and doing it manually will take a lot of time, and there will be a lot of errors. So there was no tool to do this automatically at the time, so we built our own. And basically, the Graph CLI tool has the logic to do the translation from our old vendor into Grafana Cloud and PromQL. And also, it was nice to have a place to enforce some defaults so that variables and folders and the things that we have in Grafana Cloud don't become a mess. So basically, the tool, what it's doing is managing the workflow in the sandbox environment. So it's going to talk with the Grafana API. So it reads the definition from your YAML file, and it will create a copy of that dashboard in a sandbox environment. Then you can do any change there, save it, and it will sync back those changes into the YAML file, and it will remove the version on the sandbox. But then it also had the feature to actually migrate dashboards from our old vendor into Grafana. So it will translate the schema of the dashboard itself, but it also will handle renaming the metrics because we were using StatsD and we switched to Prometheus, so we had to rename everything. And it will also be able to actually translate the query language so that you get a fully working PromQL expression. This was hard to do, and it worked most of the time, but sometimes we just break the expression, and users will have to actually check and fix those. Usually it was sort of an edge case, so most of the time this worked, and at the end of the day, you only have to fix 1 or 2 expressions instead of having to write like 20 expressions to create your dashboard. So this makes the process a lot faster for us. Okay, let's try to do a demo. So this is Argo CD. This is like a dummy environment, so we don't have a lot of stuff here, but basically this is Argo CD. It's already watching a Git repo, and it has 2 dashboards out of that Git repo. So basically, here we have like the definition that Argo CD is watching. So this Argo CD is actually creating those config maps into a Kubernetes cluster, and then we have the operator reading that config map, and it's actually creating these dashboards out of those definitions. So here we have the dashboard. Since we are in Grafana Cloud, it's really easy to use RBAC. In this case, like our sandbox environment is just a folder inside the same instance. But we can use RBAC to actually make everything read-only for the users, except for the sandbox, right? So they will be able to make changes inside the sandbox, but they will not be able to change the real dashboard. And we are storing those definitions in a GitHub repo, so we have them here. Everything is here. Okay, now how do we do a change? In this case, we already have the dashboard there, but let's say we want to make a change. So we run this graph command, and basically what it's going to do is going to create a new copy of the dashboard into the sandbox environment graph. It's going to create this panel, this text panel by default, just to provide some feedbacks. But this panel is not going to get exported into the YAML file, so I'm just going to remove it. And basically, we have the same dashboard. This is like a copy of the dashboard, and we can make any change here that we want. So let's make some silly changes to make it clear. We can even change like the PromQL expression. Okay, so now that we have made changes to our dashboard, let's save it. Okay, all good. Then we can go back to the graph CLI. It's going to show us what has changed. We can quit it. And now, this is already a clone of the Git repo. So I can check here, and I can see that there was actually some changes on the dashboard. So let's go ahead and add those changes to the repo. Okay, and let's push the changes. Okay, so now we have, if we go back into the Git repo, we can create a PR. Someone could come and review this PR and see that the changes actually make sense, so we can see here what has changed. But in this case, we're just going to merge it. Okay, all good. So now that we have the changes committed, we can go back into Argo CD. Let's refresh. So Argo CD has already realized that there was a change in the Git repo and has already seen those changes in the cluster. And the controller should have picked those changes. Oh, I think I screwed the expression, right? But you can see that the changes that I made are actually here. Let me check. I think I broke the expression. Probably I did something wrong.
Parentheses? No.
Well, I don't know what I...
Oh, the 10.
Oh, yeah, exactly. Yeah. But
I swear we practiced this 10 times.
But you get the idea. Now someone can come and fix this and make a PR to actually fix it. So now when you close the running instance of Graph, actually this dashboard shouldn't exist anymore. Let's see if that works at least. So yeah, it's showing an error because the dashboard was removed by Graph. And so yeah, that's our workflow, and that's how we manage dashboard. And that's the demo.
Yeah. Thank you very much.